Please open in your learning workbook to page 197 as we look at an example where we graph a logarithmic function. All right, here's a problem. Graph g of x equals log base 2 of x. At first, you might find it challenging to graph a logarithmic function, but if you choose values of x that are integer powers of the base, it becomes much easier. All right, so let's figure out what's the base for our log. The base is 2. So I'm going to write a 2 in all of our blue boxes over here. I'm going to refer to this as the thinking column. All right, now we get to choose 5 integer values, and we're going to use the ones that we are accustomed to choosing, which are -2, -1, 0, 1, and 2. Here's the idea. Earlier this semester, we learned our basic functions, and for our basic functions, most of the time, we picked x values that were -2, -1, 0, 1, and 2. But now we're here looking at logarithms. A logarithm is a missing exponent, which means that the -2, -1, 0, 1, and 2 are going to be the exponents of our base. This is how we're going to determine our x values. So our first x value, we'll work our way from the table bottom to top. Our first x value is 2 to the second power, which is 4. Then 2 to the first power, which is 2. 2 to the 0 power, which is 1. Notice the pattern, which is divide by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2, and that works out because 2 to the -1 is equal to 1/2, and 2 to the -2 is equal to 1/4. Okay, so now we have our x values. We just need to plug them into our equation to find the corresponding y values. And you're going to see that even though I'm going to do it the long way for a couple of these, the shortcut makes this super easy to understand. For example, let's try this one right down here. What if I wanted to find out what the y value is for x of 4? Well, just plug in. We have our equation, y equals log base 2 of x. If x equals 4, then y equals log base 2 of 4. All right, think about what this is representing. Log is EGOB. What is the exponent that goes on base 2 to make 4? The answer is 2. 2 is the missing exponent. Therefore, 2 is the value of the log, and I will put a 2 here. Now what I want you to see, this is the part where this gets really easy. What I want you to see is this statement right here. 2 squared equals 4. A logarithm is a missing exponent. The missing exponent is right here. The reason why we got 2 was because that was our missing exponent. This will always be true. Let's look at another example. If x equals 2, then y equals log base 2 of 2. Log is EGOB. So what is the exponent that goes on base 2 to make 2? The answer is 1. The missing exponent is 1. So I put a 1 here. Notice that that matches the exponent that I have. This pattern allows me to fill in the entire table. Whatever the exponent was that you used on top of the base to make x is telling you y. 2, 2, 1, 1, 0, 0, -1, -2. There we go. We have our 5 points. And now we're ready to create the graph of our logarithmic function. All right, here we go. I'll make this nice and big. Okay, so our x's go all the way out to 4. They're only positives, so we're going to be in this region. And our y's have a mixes of positives and negatives going as far out as 2 and -2. All right, here we go. Let's plot our points. Let's start with the nice and easy ones. 4, 2. So that will be right here. 2, 1. That will be right here. 1, 0. That'd be right here. 1/2, -1. Well, this is x is a half, which would be right there at that spot between 0 and 1. 1/2. So 1/2 -1 would be at this point. And then finally, 1/4 -2. Well, 1/4 is halfway between 0 and 1/2. So 1/4 -2 would be at this arrow down at this location. Now when we connect our dots, we have to remember that there is an asymptote. An exponential equation has the x-axis as its asymptote, but a logarithmic equation has the y-axis as its asymptote. So we're going to draw our y-axis with an asymptote right on top of it, and then we will connect our orange dots to make the graph of our logarithmic function so that it approaches but never reaches that asymptote. And there we go. This is the graph of the logarithmic function g of x equals log base 2 of x.